So I want to go over a couple problems that could be a little confusing. Suppose you have this. And we're given, say, a number, 27 centimeters. We have a missing number, but we're told there's a ratio 4.5 to 1. What does this mean? Well, this missing number we're going to call x. And what we want to do is find x. So what this is saying is this. It's really saying 27 to x is the same as the ratio 4.5 to 1. That's what this is saying. And what we're tasked with doing is finding x. So we use our proportions. 27 over x equals 4.5 over 1. When we construct sort of the fraction-looking form of a ratio, this is the top and that's the bottom. That's the top and that's the bottom. Now we cross multiply. (4.5x) equals 27. So divide by 4.5. And again, division is the opposite of multiplication, so that's why we divide it. So those can cancel, but we did the one side, we have to do the other. And so what we find, 27 divided by 4.5 is 6. So x is 6. And so in our chart, we would put in 6 centimeters. And that's it. Right. Now, suppose we have this, though. Let's say we have and we want to come up with a ratio. Well, the ratio, we could just do 9 feet to 15 feet is equal to some other ratio. Now, it's already a ratio. It's done in that sense. But you can reduce ratios the way you reduce fractions. We could take 9 over 15, divide by 3, top and bottom, and we'll get 3/5. So we could very well put 3/5 here, and this would be perfectly fine. It's just a reduced version of 9 to 15. Now, they might ask us to do something a little different, though. Suppose there's an insistence that the bottom number say for some reason, there's an insistence that the bottom number needs to be 12. And so we need to reduce this ratio in such a way so well, the bottom number turns out to be 12. Well, the missing number in this case is our x. So we got to solve for x. So we have our ratio. 9 to 15. And that's going to be equal to some ratio, where the bottom number is 12. We need to figure out what the top number would be if we reduce this so this becomes a 12. In other words, if we make this a 12, what does this become? We got to figure that out. So we set them up. Again, top number, bottom number, top number, and it is a number, it's just an unknown number, bottom number. And then we solve for x using cross multiplication. We have 15 times x equals 12 times 9, or 15x. And when you write the number next to the letter, again, it's the same as multiplying. It's just a shortcut they do in algebra. You could leave it like this and it would be okay. The reason we don't like to do that is it's easy to confuse multiplication with the variable x. Sometimes people will use a dot instead of that little x, so that confusion hopefully doesn't happen. All right, so I have 108. And yeah, 15 times x, we want to get x by itself. So we do that, we have to get rid of the 15 times, the opposite of multiplying by 15, dividing by 15. But the rule of algebra, and again, we'll talk all about this later. We're getting ahead of ourselves. Do that to the other side. And since they're opposites, they cancel each other. And divide 108 by 15, we get x 7.2. So what it says is this: if we want to reduce the ratio of 9 feet to 15 feet to a ratio that has a bottom number of 12, we turn the 15 into a 12. That means the 9 has to become a 7.2 if these two ratios represent the same type of relationship. So that's it. Any questions? Let me know.